welcome. Yeah, so yesterday was Thanksgiving, and I hope everyone had a wonderful Thanksgiving. And as always, may Christ be with you as He is with me every day and every minute. Okay, so now I have like this really fun integral to share, and usually you know how I present my integrals, but this is a monster of an integral, and like it would be very time consuming for me to use the usual platform, and moreover, um, you know, like wait, what was I gonna say? Yeah, so like it's also like um, a worse way of presenting something that is this much of a monster using the usual platform, because usually what I have to do is like I erase the board in a systematic way on the usual platform, and instead I'm going to use Word here and scroll down and narrate through some parts, and I'm gonna help you with a narration here because I think unlike the simpler integrals, like here it might be helpful if I talked over it in some parts, but I assure you that this is not the beginning of something new. In other words, like I'm not going to use this format of presenting integrals in the future. This is kind of a one-off. All right, let's get at it. Let's get it. As you can see, it's square root of 1 minus x over 1 minus square root of x. Some kind of like wordplay there, huh? Okay, and so what we've done here, like in the first part, is we've put a negative sign in front of the denominator. And of course, then that means that we could switch it to positive square root of x minus 1 and throw the negative in front of the integral, right? So that's all that happened in that first move. And here, we're using the conjugate of the denominator to kind of like simplify slash clean up. And this is pretty straightforward. Obviously, distributing this square root of 1 minus x in this part, we'd get this. And then distributing it to the 1, we'd get this. Otherwise, difference of squares here, right? So we're going to get x minus 1 in the denominator, because it'd be root x squared, which is x, minus 1 squared, which is 1, right? Okay, and then here we make a u substitution. So see, despite the difference in the format in which I'm presenting, all the effort, the usual effort of color coding and such, it's still here, right? Okay, alright, so we make a u substitution, and we claim that u is equal to square root of x, right? So then, that means u squared is x, because we need a replacement, say, for this x and this x and that x, blah, 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 right? Okay. And with this u claimed, du is obviously 1 over 2 root x dx. That should be pretty straightforward calculus. And not the calculus in your teeth, like regular calculus. All right, that was a little random. Okay, so then here, solving for dx, we're going to have to say 2 root x du is equal to dx, obviously. But then remember, we said root x is u, so we claim that back. So this root x is now u. So we have 2u du is dx. And then we make all these things as substitutions in what we had earlier here. So like this is u, because root x is u, and x is u squared, blah, blah, blah. And we replace dx also, and if you do that all correctly, then this is where you're gonna end up, right? This extra u is from the dx being 2u du. The du is right there. The 2's gone in front. We'd had this negative sign from the start. Everything else should make a lot of sense, right? Okay, now we distribute this u, right? Notice this u is going to be distributed in this part and in this part. And once we've done that, where you're going to end up is here. And of course, since we have a plus sign here and a common denominator, we can split it into 2 quotients over the common denominator, and that's what I've done here. So I've done a couple of things at once from here to here. But they're all pretty straightforward, so you should follow. All right. Now, this integral is a bit of a monster to do all at once. So first, using the linearity of the integral, we split it into 2 integrals, and that's this. This minus sign would be distributed to the second integral. That's why I have a minus 2 here, and not just the minus sign, but the 2 also. Pretty straightforward. And it is here where I decide to name this integral, including the constant in front, a, and then this integral, including the constant in front, b. So we're going to first work on a, and so we're going to work on this integral. So this is what we've got for that integral. All right. So now, like doing some algebra. Sorry, hold on. Let me scroll a little bit. Doing some algebra, we can see that a is the same as what I've got here. Like if you get common denominators in this part, you'll see that it will turn into, huh? Wait, what's happening with Word? Word? Okay, alright. No, it's fine. Sorry. So just do some algebra. You'll see that this is exactly the same as A, and obviously we want to move in this direction because it will make life a little bit easier. Now, -2 here will be distributed in this part, and also, again, applying the linearity of the integral, you should see very easily that A can turn into this now. And so then, now A is going to break into two integrals, C and D. And it should be pretty straightforward to see that, this is C and this is D, right? Okay, so let's work on C first. And so what we're going to say is that U here is going to be sine theta. I have a lot of videos on trig sub, so it should be very clear why we'd want to make this kind of a substitution. This is what's called trigonometric substitution. But with U being sine theta, du would have to be cosine theta d theta, right? And so continuing on our progress, we'll see that u squared would be sine squared and so on. And so sine squared theta minus 1 is the replacement for u squared minus 1. And of course, du is cosine theta d theta. So there it is. Now, remember, 1 minus sine squared is cosine squared. So just as we had done earlier at the very beginning, we're going to throw a negative in front of this, right? And so then we'd put that there, right? And that would allow us to write sine squared minus 1 as 1 minus sine squared. But wait, there was already a negative right there. And so when we put a negative here, right, and rewrite this as negative, sine squared minus a negative 1, you get it. Then this negative is going to turn into a positive, but in the denominator it's going to be 1 minus sine squared. And we've got cosine squared here. As I said, 1 minus sine squared is cosine squared. Well, so I needn't say more. So that's why this is turned into cosine squared. Square root of cosine squared is cosine, right? So we get a cosine here, but we already have a cosine here. So together they're going to turn into cosine squared. And then 1 minus sine squared, as I said already repeatedly, is cosine squared. So this ends up being cosine squared over cosine squared. All right, but that's 1. And the integral of 1 d theta is just 2 theta, right? And so 2 theta plus a constant. So here we are. Now, remember, we'd said that u is sine theta. So then that means that sine inverse u is theta. So then we replace this theta with sine inverse u. And also, you should remember that very early on, we'd said u is square root of x. So then we call that back, and so we're done with C. D was the simpler of the two parts into which we broke A, right? C plus D. D was this. Okay, once again, the correct substitution to make here is to claim that u is sine theta. So in a way, we could have done it all at once, but it's better. I like to do it piecemeal. All right. And so then it should come as no surprise what du is. We make all these substitutions and we get minus 2 cosine squared theta d theta. Now, I already have a video on how to integrate cosine squared, and so I'm not going to do that here. And if you do it correctly, the integral of cosine squared theta d theta is 1/4 sine 2 theta plus 1/2 theta, right? And so we substitute that. This minus 2 is the constant that was in front of the integral, and so here we are. Now we distribute the minus 2 and reclaim, based on u being sine theta, that theta is sine inverse u. You've seen that already. And so we put all this together and we see that the integral d and is going to turn into this. And we distribute the minus 2 here to all the constants, and so we're going to get this. And obviously this 1/2 times minus 2 is how we've gotten a minus sign right there, and so on. All right, so we are done with D. Remember, we'd broken A into C plus D. So the only thing we have left is to work on B. And remember, the integral I was a plus b. So we go all the way back and recall that b was this, right? Okay, so now we say that v is equal to the square root of this quantity, right? Okay, so then dv is going to be 1 over 2 times this quantity, and then chain rule times minus 2u and then du, right? And since square root of 1 minus u squared is v, I've claimed it here. And so this kind of simplifies nicely. So the 2's, well, I haven't canceled them, but they will cancel eventually. But like, we multiply both sides by the reciprocal of this to get du by itself. And so that's this here. Now, we substitute all this into b. And so we had u, and this is v, right? And so we've got uv here, and this is the replacement for du. Otherwise, this denominator should come as no shock. And here, finally, I cancel the 2's here. And this u is going to cancel that u. And this v is going to multiply that v. So we have v squared. Y'all should be good at algebra if you're watching a video on this monstrosity of an integral. And so I needn't say too much. And now, from here, right, since v is equal to this here, and that's a substitution we made, I'm going to say v squared is equal to 1 minus u squared. And I solve from there very easily for u squared. Just move this to the left and move this to the right. And so u squared is going to turn into 1 minus v squared. And we want to do that because we want to make this integral all about v, right? Not all about you. It's not always about you. It's all about v. I mean me. Okay, so, I mean no. It's all about Jesus. Okay, now, since this u squared is 1 minus v squared, right here I have 1 minus v squared replacing the u squared, and then you get 1 minus 1 here. That's going to cancel, right? And so you have v squared over negative v squared. Okay, so we throw the negative from the negative v squared in front of the integral with the 2, and we get this. Otherwise, what we've got is integral of v squared over v squared, and that's just going to be 1 dv. The integral of 1 dv is just v, but we've got the minus 2 there, so we get minus 2v and then plus c, right? Okay, and now remember v was the square root of 1 minus u squared, so we bring it back, and here we are. And finally, finalement, since u is equal to the square root of x, we replace this u with square root of x, and so we get square root of x squared, and that's just x. And so here we are, and so b is finally going to turn into simplifying this, right? Okay, now putting all this together, remember as I said from the beginning is a plus b. So then a plus b is going to end up looking like, okay, sorry, it won't scroll. It's because I needed to go to a new page. Alright, so I was on the final page, sorry. So putting all this together, we get a plus b, so that's all of this, right? Okay, I hope you enjoyed this, and once again, I hope you had a great Thanksgiving, and have a wonderful weekend. I will talk to you sometime soon. Take care. Bye.